Okay, today we're going to start chapter 11, which has to do with probabilities and odds. So at the top, it says a possible result of an experiment is an outcome. For instance, when you roll a number cube, a number cube is just what every single math text calls a dice. So just a regular six-sided dice. But there are six possible outcomes: 1, 2, 3, 4, 5, or 6. And then an event is an outcome or a collection of outcomes, such as rolling an odd number. The set of all possible outcomes is called a sample space. So on number 1, it says you flip a coin and roll a number cube. How many possible outcomes are in the sample space? So last year we learned something called the counting principle, and that was where you multiply your options. If you're making more than one choice, you can multiply those options together to get the total number of choices. So if you're flipping a coin, how many choices are there? How many possible outcomes are there for flipping a coin? There's 2. And then when you roll a dice, how many possible outcomes are there? 6. So 2 times 6 is 12. Okay, but what we are going to have to do this chapter, and there's only a couple of them on your homework, but we're going to need to list out the possible outcomes. So for example, when you flip your coin, could get heads and then a 1 when you roll your dice, or you could get heads and then a 2, or heads and then a 3, or heads and a 4, heads and a 5, heads and a 6. Okay, or you could get tails and roll a 1, tails and roll a 2, tails 3, tails 4, tails 5, tails 6. So these are our 12 possible outcomes, and this right here is called your sample space. So on example 2, you're going to be flipping not 1 but 2 coins and then rolling a number cube. So if you flip a coin, the first flip, there's 2 choices, right? Or 2 outcomes. The second flip, there's 2 outcomes. Now we're rolling our number cube, 6 outcomes. So we're going to end up with 24 numbers in our sample space. So if it's harder for you to keep track, okay, which it can be when you're dealing with 24 outcomes, let's see, I'm probably going to run out of space on here. That's okay. You can make a tree diagram, which is what we did last year. So for example, on your first flip, you could get heads, right? And then your second flip, or first flip, sorry, you could get heads or tails. Second flip, heads or tails. And then under you could get 1 through 6, 1 through 6, 1 through 6, 1 through 6. So this can kind of help you when you're listing out your sample space. So you could have heads, heads 1, heads, heads 2, heads, heads 3, or heads, heads 4, heads, heads 5, heads, heads 6, or heads, tails 1, heads, tails 2, I'm having a hard time writing this, heads, tails 3, heads, tails 4, heads, tails 5, heads, tails 6, or tails, heads 1, tails, heads 2, tail, head 3, tails, heads 4, tails, heads 5, tails, head 6, or tails, tails 1, 2, 3, 4, 5, and 6. Okay, so the next part says the probability of an event is the measure of the likelihood or chance that an event will occur. Probability is a number from 0 to 1, and it can be expressed as a decimal, a fraction, or a percent. So if this is 0, that's 0%, right? And then it goes all the way to 1, which is 100%. So right in the middle would be 50%. So essentially, it's like how likely is something to happen. So 0% chance would be like, there's a 0% chance that I will eat fish today. I hate fish, I hate sushi, 0% chance of that happening. There is a 100% chance that I will drink hot tea today because it's my favorite thing. I drink it every day. Okay, there's probably a 50% chance that I will go to bed before 10 p.m. Okay, so these are how probabilities are kind of on a scale. So the outcome for a specified event are called favorable outcomes. When all the outcomes are equally likely, the theoretical probability can be found using the following, and that is favorable outcomes over total outcomes. Okay, so for example, you and your friend designed t-shirts with silk-screened emblems, and you are selling the t-shirts to raise money. The table below shows the number of t-shirts you have in each design. Okay, so we have 10 red or green with gold, 8 green with silver, 6 red with gold, and 6 red with silver. So a student chooses a t-shirt at random. What is the probability that they choose a red t-shirt? So there are 30 total t-shirts, and how many of them are red? 6 and 6 would be 12. So the probability of them picking a red t-shirt is 12 out of 30, which we can simplify to 2 over 5. We're going to write our answers today as simplified fractions. Okay, and then on to the back, number 4, in the previous example, what is the probability that the student chooses a t-shirt with a gold emblem? So gold emblem, 10 and 6 would be 16 out of 30. Those are both divisible by 2, 8 out of 15. Okay, number 5, it says you toss, not Ross, a coin and roll a number cube. What is the probability that the coin shows tails and the number cube shows a 4? So tails is a half, and then how many 4s are on a dice? 1. So 1/2 times 1 over 6 is 1 out of 12. And if we flipped it over and looked right here, right, this is essentially that problem. We're going to flip a coin and roll a dice. So what are the chances? What was it? Tails and a 4. So here's tails and a 4. That's 1 out of my 12 choices. Okay. An experimental probability is based on repeated trials of an experiment, right? On number 5, we weren't actually rolling a dice or flipping a coin. It was just, in theory, if you roll a dice 6 times, you should get a 4 once. Okay, that's not based on data. Experimental probability is based on repeated trials of an experiment, and the number of trials is the number of times the experiment is performed. Each trial in which a favorable outcome occurs is called a success. So on example 6, it says each section of the spinner shown has the same area. Okay, obviously it's not color. We have red, green, blue, and purple. Okay, we're going to spin that spinner 20 times. So it says the table shows the results for which color is the experimental probability of stopping on the color the same as the theoretical. So let's think about, in theory, if I spin this 20 times, how many times am I going to get red? 5. How many times am I going to get green? 5. 5 and 5, right? If it's 20, I should get, in theory, 5 of each of these colors, 5, 10, 15, 20. So in reality, I got 3 purple, 3 blue, 9 green, and 5 red. So red is the only one that I actually got 25% of the time. Okay, so now we have to talk about odds. In probabilities, we were comparing the favorable to the total. Odds in favor are going to be written as the ratio of favorable to unfavorable, and odds against are unfavorable to favorable. So it says in example 6, find the odds against stopping on green. So there's 9 green, and that means there's 11 that are not green. So unfavorable is 11 to favorable is 9. And then odds in favor of stopping on purple, 3 purple, 17 that are not purple.